Okay, how's everybody doing today?
Good.
Alright, today we're going to go over the common shapes using structures. So they're drawn up on the board. We have a triangle, an arc, a cylinder, a rectangle, and a square. Can anyone guess which one of these is the strongest?
Triangle?
Triangle is the strongest. Alright, and we're going to go over why. So a triangle, first of all, obviously is this one. It's a plane that's connected by 3 points and straight lines. Its characteristics are it's very stable, and like I said, it's the strongest shape. So it is used in trusses and other truss systems like in rafters. It is the strongest because there's going to be, on all these we're assuming there's a force coming from the top. So if the force is coming down from here, that's a force, then there are going to be two different forces acting on the triangle. You're going to have compression forces that push down this way. So I'm just using C and T for compression and tension. And tension forces that run across the bottom. These tension forces balance out the compressional forces, which make it one of the strongest to use. Okay, if we move over to the arc, same thing. We've got a force coming down from the top, and our tension this time is going to be across the top, and our compression is going to be across the bottom. So this line is going to be compression, and our tension is coming over here. Can anyone name me a famous arc?
Noah's Ark.
St. Louis.
Noah's Ark. Noah's Ark is a famous arc, but I was thinking construction, so St. Louis is correct.
McDonald's.
McDonald's does have the golden arcs. Alright, and an arch is also used in domes and in barrel roof systems. Okay, we're going to come over here to cylinders. Cylinders are the third strongest. They're often used in columns, and they support great weight, and like I said, they're using columns and posts. So a force is going to be acting from the top, because a column is going to be in a 3D form. So this is the force that's acting in the center of the column. The cylinder works by spreading out the tension. So the tension forces are going to break off from the center and be just forced all over the top of the post. That's why it's so strong, and the rest of the compression forces are coming through there. Okay, and now we have a rectangle. A rectangle can be used in three forms. It can be used like this as a post. When it's used like this, the force is going to be coming down from the top, and obviously it's going to be 3D as a post. So the force in this is using just the compressional force. So the compressional force is going to go through the middle. Pretend that's actually in the center. Not tension, sorry, it's compression. It's actually going to be in the center of the object. It is not one of the stronger ones because there is no tension to offset the compressional forces.
So they don't all have to have the T, they all have to have the C, but not the T.
Right. Well, they all have a C. The stronger ones are going to have the T to counteract. The tension, which is the T, is the counteracting force of the compression, and it makes the thing stronger. So the ones that don't have the T's are actually the weaker forces.
Now, how about the E? Do all of them have the E?
Where do you see an E?
The first one is an E.
Oh, sorry, that's not supposed to be an E, that's supposed to be an F, just for the force. So, sorry about that.
Oh, I see. I'm sorry.
No, that's my fault. It's just an F for the force. Okay, another way, does everyone have this down in the notes? Sorry, we need to take notes on this because this is going to be used in our project and it's going to be tested. We're going to be tested on it. So, rectangles can also be used in another way. So if everyone has this down, let me erase it and change it up. Is everyone okay?
Yeah.
Alright. They can also be used like they're using rafters. In that case, they're going to be sideways. So here, we've got a force acting upon the middle, like always. This time, the compressional force is split in the middle. Oh yes. Yeah, compression. And then tension forces are acting on the rafters. That's why rafters are used to hold up structures in the ceilings, because they're actually a little stronger. As the compression forces down, and this is forced down, this is going to try to bend upwards. Like it's gonna buckle up. So there's going to be tension on the bottom as these ends try to pull up with the rest of because of the force. Okay, and last but not least, we have the square, if everyone can see it. So we've got a force acting here. Two compressional forces act on the square. They come down here and down on this side. So they come down on both sides. Square has no tension to reduce the stress, and squares are pretty much the weakest of the structures. But we can strengthen a square shape. Does anyone know how?
Triangles.
Triangles in a pyramid, basically. You're going to use a diagonal from either side, and as you can see, this is going to take, if you put that diagonal in there to act as support, the tension is going to be used on here, and it's going to make it stronger. But as Cheng said, we have two triangles, so again, you're just using a triangle as the strongest force. There's the strongest shape. So, in review, can anyone name the common shapes that are used in structural systems? Anyone need to shout them out if you want to.
Cylinder.
Cylinder's one, arch one. We've got triangle, rectangle. Someone said square. Square. And that's all five of them. All right. Can anyone tell me which one is the strongest again and why? Okay, it's the strongest because it's connected to the bottom, and the tension equals out the compressional forces when the force acts straight from the top. And can anyone tell me the second strongest of the forms?
The arch.
The arch. And it is the second strongest because it is also counteracted, the compression is counteracted by the tension, but it is not connected to the bottom, which makes it a little weaker than the triangle. So if anyone has any other questions, let me know. And what I would like you to do for the rest of the class is go around the room and observe any shapes that we went over today and write them down and tell me how forces are acted on them and why that was a good idea to use that shape in that kind of structure. All right. Thank you.
Along with that,